I started to mention, which is a quiver in mathematics. And from what I've looked at, it is a little bit similar to the different arrows that I'm using in my graph. And in a sense, sometimes they're a little bit like functions. They're definitely vectors. I think that's really the main way to think about them. They're vectors essentially, with different qualities to them, which are denoted by the arrowheads and the way that they're all interconnected. It's a little bit like MaxMSP. MaxMSP, the programming environment, the real-time coding environment from Cycling 74, which is also sometimes just called Max. MaxMSP Jitter. There's various ways of saying it. That particular piece of software, which is a sort of 6 level language, allows you to do this kind of prototyping where you have signal flow along one chord, a little bit like an analog synthesizer, and then you have your data coming on another one. You can also then incorporate all sorts of other kinds of data types into that system, such as matrices, which are used by the Jitter, which is the video platform, and there are fundamental data types that are associated with the back end to Max, which were established by Max Matthews back at its birth in the 80s. It's based on the music end languages. So I guess what you're ending up with there is a situation where you've really started out with a musical logical basis for this computer music oriented production software, which has eventually become a multimedia music production and other system. It's got nothing to do with music unless you want it to be. You can even make a computer game in it, really, if you want. Now, it's inspired by that, but it's definitely heading in a majorly different direction. And I'm pretty sure that this could be implemented in Max MSP, so I'm still trying to do that, but yeah, we'll see. Okay, cool. So that's all I wanted to say about mnemonics and worldviews. Now I'm going to head over to the graph. So this is the second graph that I created. This is the first one. So I'll see if I can explain to them some things with this first graph. So this is the concept of X world space. This is X. Now I've chosen to use a sphere to represent X. I didn't have to do that. I just think it's easier because you can basically, X could be infinite, and so then there's lots of space to connect up arrows. You're never ever going to get everything that pertains to X in every way for every single actor in the environment. That's not really that important. You're trying to filter out information more than anything else. There's so much information out there. This is the problem. You need to then somehow structure it and break it down in order to compose with it. And the current system that we have is just really not adequate. There's no way to really delve deeply into and rapidly prototype music, art, those kinds of things in a way that's really related to music notation. I know there are a lot of ways to do similar to stuff to this, but I think this is a good way. I think it's a very good way to do it. So X is here, and there's lots and lots of space to connect up our arrows to X. And there are a couple of different actors. This point I originally called the end point, so there's a little bit of an artifact of that left in some of the descriptions, but I've changed this to M. So this is now M, and we are M. And in fact, in the other graph, I've actually put you are here at the M point. But we are M. We are M, and we are at the end point. Sorry, not the end point. M is at the end point. End point being the point where all the mnemonics are. So let's just imagine that we have a mnemonic here, which is, sorry, a neum here. There's a neum here at our endpoint, and it's composed of the n1, which is inherent to the neum. It's then got a neum at n2, which is, in this case, I've just gone for a square. I've gone for a rectangle. No real reason to do that, but I'm trying to show the black box nature of this particular idea. Now, in realization, this composition could contain anything here. I've just put a square there for now, so just, or an oblong, or whatever you want to call it. Just leave it there for now. So that's a distance of n1 from our n point, where we're viewing the world space from. And I've denoted that by using this weaker arrow to put that connection together. And we'll look at the key over in the next graph to look at that a little bit better. And then that's connected up to distance of n2 from n3, capital N3, which is a mnemonic called N3. I've chosen to give it this shape so that I've got lots of nice space to connect things to. And that's also N1 from the N2 idea, the black box here. So these two black boxes, this is N1, the mnemonic for the concept of X, and our concept of X is made up of N1, N2, and N3 at this stage. Now, N3 is also influenced from X itself. Now, X is sort of the memeplex, and this is the out there somewhere idea. So the idea, this graph is, I guess, in a way trying to explain specialization in a sense. So A, which we'll get to in a minute, is naive to language, naive to state of mind, to theory of mind even. So X, which I have mentioned a few times, is related to green in a lot of different ways. So X is actually the color green. So this is our animal artificial neural network or whatever, what have you. Its exposure to this X concept is only available via, and in this case I've decided that it's got two inputs, and these are ocular, and so I've decided to use light, at least they're light. So the idea is that this particular color, pattern of light, is interpreted by something in this A, and so what it knows at this point, and this is all about knowability, is that this and this are X, and the only thing that has told it that is X itself. And so this evolved into something more like this in the next graph, where anything that comes from X, this is to show signal flow, I guess, from the memeplex itself, is denoted with these large block stars. I've used color here to denote what's traveling along this line. I know this is a limited way of doing things, but I'm trying to show that there's parallel transfer going on. So there's no kind of back and forth. There's just the idea of the memeplex, and then there's the A is looking out, and it just sees these two kinds of light coming in. So that's sort of without really going into any detail about what could be happening inside A, but this is all that is going into A. So A is almost A is another kind of black box. And I've said here of x1 and x2 over a distance of n1. I haven't written n1 here, which I probably should have, but x1 and x2 are just variables within x, which have been transmitted. And in this case, I guess x1 is this color and x2 is this color. Now, I won't continue along with that graph for much longer, because I did change a lot of these concepts as I developed it, but I think that's pretty good basic introduction. So I'll pause it there, and I'll head to the next graph to go into a bit more detail about how the world space can be used to explain memeplexes.